The whole world of electronics, from phones to laptops and everything in between, run on bits of information. These can exist in two states, either 1 or 0, and combinations of these can allow us to do all the things we love to do on our computers. But recently, scientists discovered a new type of computer, a quantum computer, which relies on entirely different technology and may just revolutionize the world. To see how, let's understand some quantum physics. In the 1900s, two very contradictory experiments were performed. One that showed that electrons behave like particles, and the other showed that they behave exactly like waves. This was really shocking for scientists at the time, as they found themselves with two totally different but accurate views of what electrons can be, and could not choose one view over the other. They realized that the only way to solve such a conundrum was to combine the ideas together. That's right, they realized that electrons can act as both particles and waves. They realized that electrons are particles that exist in a wave of probabilities. This means that electrons can exist in multiple states at once, each state having a different probability of existing, known as quantum superposition. But every time a measurement is made, the whole superposition collapses and the electron conveniently finds itself in one of those probable spots. Understanding this concept is key to understanding quantum computing. Consider the spin of an electron, which is basically its orientation in a magnetic field, just like the needle of a compass. An electron can either be spin up or spin down, and through superposition can exist in both states at once, until measured. By attributing a number, 1 or 0, to each state, you can form a bit that is both 1 and 0 at the same time, known as a quantum or qubit, which forms a quantum computer. And these are a game changer. For every 2 qubits you have, you can form 4 configurations of regular bits at once. With 3 qubits, that would increase to 8 possible configurations. And extrapolating this pattern, with n qubits, you can have 2 raised to n possible configurations of regular bits, which is exponentially larger than a regular computer. And that's why, for certain problems like factorizing integers, using a quantum computer is like being able to traverse a maze by exploring all parts at once. Unlike a regular computer, which would have to try each path and take much longer. This concept is still in its infancy. It can only solve a very particular type of problem, because it's really hard to manipulate superposition. It's still amazing to see how combining physics and technology together can result in new ways of seeing the world. I'm Smayan Khanna, thank you for watching.